Okay, so in the first video, if you'll remember, our final answer was x plus 7 over x minus 3 times x plus 2. And we're trying to go back with a partial fraction decomposition. We're trying to go from this to back to the original rational expressions that we had. And you might be looking at that going, well, how are we going to do that? Good question. Okay. Also, I want to make mention that you can multiply out that denominator. I don't usually multiply them out because, eventually I have to work with the factors, but, oops. But you could have written the multiplication out. You could have had that. Okay. So in our first partial fraction decomposition, we're going to look at the denominators, and this is what we're identifying. Notice that this is a linear factor, and this is also a linear factor. So both of those are linear factors. Okay, so this first example that we're doing has to do with if your denominator has linear factors, like in this case. And now, if you're saying, well, what's a linear factor? It's where you have x to the first power. That's the highest degree, right? Okay? All right. So here's the thing. If you have a partial fraction, so some, polynomial in x over another polynomial in x, and these are polynomials, okay? So you have, that situation, and the degree of p of x is less than the degree of q of x. Okay, and q of x, well, it's made up of linear factors. Made up of linear factors. Okay, so now I'm going to give you the generic formula here. So it's a little hard to read sometimes, but all right. Say you have, P of Q, you have this situation, just like I had described above, and we're going to say that can be split up into these different rational expressions, and we don't know how many there are. Depends on how many linear factors you have. But in the denominator, you have linear factors. So say you have n factors. Okay, for n linear factors of q of x. Okay, so in other words, you have a denominator and it can be factored into so many linear factors. Well, then that's what the denominators look like. You take each linear factor and you may give it its own denominator, its own expression. What about the numerators? Well, the numerators have to have a degree less than the denominator. So you can only have like a constant up here. Now, when I go to write out my example, I'm not going to use this notation. This is just for a generic case, so you have n linear factors in the denominator. But for us, they're not going to be that big. We might have 2 or 3 linear factors. So, like if you're thinking, oh my goodness, I need to get more note paper because these problems could be huge. They could be, but, we try to be reasonable, and they're probably only going to be 2 or 3 linear factors.